This video is designed for new users of the BE FREE Ortho K lens and software platform. It will provide instruction on how to enter your topography data into the BE FREE software to generate a highly customized next generation of orthokeratology lens. Medmont topographer users or practitioners with an instrument directly coupled with the BE FREE software should see the videos on the automatic upload of your maps through the CloudLink tool. This video is specifically designed for users without the CloudLink to provide instructions on the data collection required. Once you complete this Part 1 video on compiling the necessary patient and topography measurements, go on to Part 2, which will describe entering and processing the orders in the BE FREE platform. To construct a lens specific for each patient's age, refraction, eye size, shape, depth, and toricity, the BE FREE software requires a small amount of easily acquired patient data. Let's review what needs to be collected. Of course, the patient's refraction will be necessary to provide the appropriate therapy target. This will be used along with the patient's age to design distinct optics for the adolescent or adult eye. Constructing age-specific optics is one of the unique features of the BE FREE lens. Each lens is designed from the thousands of data points collected by the corneal topographer. It is therefore important to capture optimal topographies to assure accurate data going into the BE FREE software and a high first fit success. Minimize lid interference and eyelash shadows to maximize coverage on the cornea. For placido-based topographers, have the patient blink frequently during capture to maintain quality reflection of the rings off the tear film. The importance of the pre-orthokeratology topography cannot be overstated. The baseline map determines candidacy, determines the initial lens, determines the first fit success, and ultimately the efficiency of orthokeratology practice. Never take just one map. Always capture multiple images of each eye. Remember, you have a sensitive camera with an unsteady patient, moving eye, and a tear film constantly in motion. Reproducible maps provide confidence in the accuracy of the captures. In this example, one of the topographies appears to be a rogue or poor scan, possibly from tear film breakup at the moment of capture. As you can see, it looks different from the others. Throw out this topography and average the data from the other three, or use the map with the best coverage and smoothest contours to design your BE FREE from. Remember that the better your map data, the more likely you are to achieving first fit success and practice efficiency. To design the ideal diameter of lens for the patient, the visible iris size is important to collect. The BE FREE software customizes the lens diameter for each eye. Take an accurate white-to-white measurement so the correct diameter of lens is calculated by the software. From the beginning of your eye care career, you have probably become very accustomed to measuring, assessing, and prescribing based on the keratometry readings. However, Ks measure the eye at 1.5 millimeters from the apex, or a 3 millimeter diameter. This does not provide an understanding of the peak of the cornea and often its steepest point. The BE FREE lens is built based on the analysis of the center of the eye to the periphery where it lands. To do this, one of the critical measures is the apical radius for both the flat and steep meridians. It is also known in some topographers as the RO, or radius at zero distance from center. Many topographers provide this data in their standard analysis outputs. Your instrument supplier may be able to assist if you don't easily find this value. Eccentricity is the final specification we need from our corneal topographers. Along with the apical radius, the eccentricity is used to calculate the shape, depth, landing, toricity, and edge lift of our highly customized BE FREE lens. Most, if not all, corneal topographers provide the eccentricity somewhere in the software that is generally easily accessible. Collect the flat and steep meridian eccentricity over an 8 mm chord diameter of measure. Again, your topography supplier may be a resource here to assist with locating this important eye-shaped data. At times, quality topography data can be difficult to acquire. An uncooperative patient, incredibly small fissure, intrusive eyelash shadows, or poor tear film quality could hinder map capture. Additionally, some topography screening instruments only provide limited shape information. In cases where apical radius and eccentricity are unavailable, K readings can be used as a secondary option, although not ideal. Remember that Ks afford an understanding of the average flat and steep meridian curvature at a 3 mm diameter. This doesn't provide as comprehensive an appreciation of the cornea as the apical radius and eccentricity, which gives the software the full picture of lens construction. Use an average and assumed eccentricity of 0.5 for the flat meridian and 0.4 E for the steep meridian inputs when entering K readings in the absence of corneal topography data. In review, the patient and topography data we need to collect for the BE FREE lens is the date of birth, the RX, the visible iris diameter, the flat RO and E, as well as the steep RO and E. These measurements will make it possible for you to construct next-generation Ortho K lenses for your patients. In many cases, this data is readily accessible on your topographer's main or detailed analysis windows. Reach out to your topography supplier for assistance if you are having a hard time acquiring this information. Additionally, the Precision and Cardinal team are also here to help. Once you have collected the patient and topography information, you're ready to go to the BE FREE software and begin calculating lenses. This concludes part 1 of this BE FREE video on data collection for non-CloudLink users. Part 2 will describe entering, constructing, and processing in the BE FREE software. If you have any questions about the BE FREE lens or this video, please do not hesitate to reach out to the Precision and Cardinal team. Thank you.